In this lesson, we're going to learn about variation problems, and there are several variations of variation problems. There's direct, inverse, and joint variation. So let's just kind of see how it all fits together. What happens to the area of a rectangle if the width is always 2 and the length increases? So I've made a table here. So the width is going to always be 2, so I'm going to make that always be 2, and the length is going to increase, so I'm going to go 1, 2, 3, 4, and then the area then would be length times width, so 1 times 2 is 2, 2 times 2 is 4, 6, and 8. So if I plot the x value being the length and the y value being the area, I'd have 1, 2, which is here. I'd have 2, 4, so 2, 2, 3, 4. I have 3, 6, 1, 2, 3, 4, 5, 6. And then I have 4, 8, which a little bit goes off right there. And if I had 0, it'd be 0. So you can kind of see kind of the direction it's going that way. So here. So we'd say as that the length increases, so as we go from left to right and the length gets bigger, the area, which is vertical, also is getting bigger, so the area increases. So as the length increases, the area increases. The equation for this graph would be y is equal to 2 times x. It is said that the area in this case varies directly as the length, and 2 is going to be called the constant of variation. It stays constant as it did right there. All right, so now consider a rectangle with an area of 6. So we're going to make a table with the possible combinations of length and width. So the area is always going to be 6. And so we could do, 1 times 6 and 2 times 3. We could do 3 times 2. And we could do a 6 times 1. So length is different in all those situations, and width is going to make it multiply to be 6. So this time I have length horizontally and width vertically. So I'm going to plot 1, set 1, and then 6, which is here. I have 2, and 1, 2, 3. Then I have 3 and 2. And then I have 6. And a 1, so you can kind of see it seems to be going here as we go there. As the length increases, so again the length gets bigger, this time the width is getting smaller, so I'm going to say the width decreases. For this problem, it is said that the width varies inversely as the length. So in variation problems, the quantity that is constant, which was the width in the first, and the area, which remained 6 in the second, is called the constant of variation. So direct and inverse variation, if the statement says that y varies directly as x, it translates to this: y is equal to k times x. So this statement translates to this algebraically. And when I see y varies inversely as x, I will say that y is equal to k divided by x. And in both of these situations, the k is the constant of variation. So let's try working through a problem that involves this. And you can see I kind of highlighted this. These problems always come in 3 sections. It'll state the variation, that y varies directly with x, and then it will give us some facts that y is 24 when x is 3 in this particular situation. And if that's true, you want to find y when x is 10. So if y varies directly with x, then I'm going to use this translation right here, that y is equal to k times x. So now, once I do that, then I'm going to come in and substitute that y is 24 when x is 3. So y is 24, and this is now going to say k times 3. And then I'm going to solve it for k. So I'm going to divide both sides by 3 and get that 8 is equal to k. And this 8 is called the constant of variation. So when you're asked to find the constant of variation, this is what you're going to need to do. State it, substitute, and solve for k right there. So now I'll take this, kind of give myself some more room. I'm going to come up here, and I'm going to do the blue part of this. But now what I'm going to do is, now I know what k is equal to for this problem. K is equal to 8. So what I'm going to do is I'm going to come over here and say that y is equal to 8x. And this is called our equation of variation. So for this particular problem, the equation of variation with the information given us is y is equal to 8x. And now we want to solve it for the blue section of it. So I'm going to put a little blue mark right there. So now what I'm going to do is I'm going to put the y, find y when x is 10. So I'm going to say that y then is equal to 8 times 10. So y is equal to 80, and that's my final answer. So there's actually 3 things in there that you can get asked for. You can get asked for the constant of variation, which in this case would be 8. You could be asked for the equation of variation, which would be y is equal to 8x. And then you could actually be asked to find y, and y is equal to 80. All right, so we're going to do one more. We'll pick up on the second video here.